Good day to everybody. I think we're going to talk about equations today. You don't see me, but you see some vocab up there. These are the main vocabulary terms for the equations unit, talking about algebra and things like term, variable, coefficient, expression, equation. And although these might not be textbook definitions, they do give you a little bit of an inclination of what you're going to be working with practically in the class. Some examples, how to locate them and how to identify them in the math that you'll do, and also just some reminders. These are just some really short, kind of 1 or 2 word definitions, just something to kind of kindle your interest in it and get you to look at some of your other resources as well. This does not replace any actual definition work that you might do in class, but it'll just be good to supplement it. If you want to pause this, go ahead and pause this, because we're going to move on pretty quickly to some actual solving of equations. And okay, here we go. So I'm going to move over here a little bit and maybe give myself a little room to write some stuff. So good day, everybody. Take a look at some equations here. These are some examples of adding and subtracting equations. And I got my purple marker here. Hopefully this can show up a little bit better. If I think I might be in the way here, so I'm going to move over here. So if you can't see me, then tough. You can at least hear me. As we look at some addition and subtraction equations, we notice that we have a variable, which is another way of expressing an unknown value. And we see an equal sign, so we know this is an actual equation, whereby if it did not have an equal sign, it would be an expression. Going back to the vocab a little bit, vocab is really important. When we talk about this particular equation, n plus 6 equals 18, we want to find the value of the unknown number by doing what we would call the inverse operation, or the opposite operation. And so the opposite of adding 6 would be to subtract 6. And I'm a little peculiar about how I solve my equations. I want you to show your work, and if you have never seen this before, take a look and see if you like it. I like to separate the equation right down the middle where that equal sign is. That way I can keep my balance. Algebra is about balance, and whatever I do on one side of the equation, I must do on the other side of the equation. So if I'm going to subtract 6 from one side of the equation, I want to subtract 6 from the other side as well. Now, the only reason for me to actually do the opposite operation of what's next to that variable is to get it by itself. To get it alone, to isolate it, that's how you'll hear it in maybe 7th and 8th grade and so on and so forth. So I want to do the opposite operation. So I want to get rid of this. That cancels out. A plus 6 and a negative 6, they cancel out. It's almost like taking 6 green Apple Jacks and 6 red Apple Jacks and eating one at a time. Green, red, green, red, green, red, until I have nothing left. This cancels out. So all I have left is my n, my unknown number. And by doing one simple operation, 18 minus 6, I could find the answer. So this is solved. N does equal 12. And if I want to check my work, I can simply take that 12 and put it back in there for that n. And I can ask myself, does 12 plus 6 equal 18? Yes, it does. It is an equation. And it is solved. So I want to take a look at p minus 3 equals 10. I'm going to split that down the middle, so to speak, and I find that my operation that's being done next to that p variable is subtracting 3. The opposite is, I'm going to balance my equation here. I like to cross that out sometimes. Can't see that. I like to cross it out just so I can say it's gone, I canceled it, and p equals 13. Taking a look at the next equation here, and if you have to pause, guys, obviously pause, write stuff down, write down questions, comments, concerns, whatever you do during your normal note-taking process. I have subtracting 10. There's my inverse operation. Here's my balancing going on. That's gone. M equals 40. And you can say that 40 equals m. There's nothing wrong with that. I like to flip it around and make it m equals 40 only because it sounds better, and it's a way of addressing the variable's value in an appropriate manner. If I want to check my work, I can simply take that value and place it where the m is. I'm substituting here, and I can say 40 minus 10. Does it equal 30? Sure does. If I take a look at my t plus 80, and it's okay to have a t as a variable, although you won't see it very often because some people get confused between a t variable and a plus sign, especially if it's poor penmanship, of which I am guilty. The opposite operation here is, hopefully you picked up on that. I'm balancing my equation, getting rid of what's already canceled out. Congratulations. and t equals, come on, okay, good job, t equals 20 or 20 equals t. So I gave you a couple of examples that I want you to try yourself, and I want you to bring those to class with you as a part of your note-taking process. Hopefully you can see those, and by my look you can see the first two, so let me angle this down a little bit so you can see the rest of them. And take a pause if you need to. And I'm going to raise this back up a little bit because we have some stuff that's on the next board. So here we go. We're going to move on to some other types of equations. I like to call these multiplication equations, and even something called division equations, even though that's not like a legal term. I like to call it that anyway because we are using different operations, and I don't know, that's just me. Anyway, the math works though. I want to remind you guys again, use inverse operations. And pause if you need to take notes, pause if you need to write stuff down, to write down complaints, comments, concerns, lyrics, rhymes, prose, whatever you need to do. So we have a multiplication equation of 5y equals 20. And this is another way of saying 5 times y equals 20. I tell people sometimes if you don't like the way this looks with a number next to a variable, that you can put that multiplication dot there if you wish, just so you can get some further context to it. 5 times y equals 20. Well, the opposite operation of multiplication is division. So I am going to divide this value by 5, and that's going to allow me to cancel out that 5, which is called a coefficient. Coefficient in a variable, the entire thing is called an equation. The coefficient is a factor, and factor is it denotes multiplication. A factor that's connected to that variable. Think about co-pilot. Co-pilot works with the pilot. Co-captain on a cheerleading squad works with the captain. Coefficient works with the variable. And the only way that you can kind of break that up is to do the opposite operation, which in this case would be division. But I still need to balance my equation. So whatever I do here, I must do here. I got to keep things balanced out. That's why you see a lot of balances, literally drawn balances, which we'll see in another video, where we're showing that whatever needs to be done here, it needs to be done here so that things don't get out of kilter. This canceled out. 5 divided by 5 is simply 1. And what I tell people is this: if you have the same number being divided right here and you get the quotient of 1, then that makes sense because how many y's are there? Just 1. Just a little kind of mental trick. So this cancels out and y is left by itself, and 20 divided by 5 is 4. Now if I wanted to check my work, I could simply substitute this 4 for the y and say 5 times 4 does in fact equal 20. Easy stuff. 50 equals 2b. I'm going to split that in half again like we did before. And 2 times b equals 50. The opposite of multiplying by 2 is to divide by 2. So I'm going to do just that. I'm going to cancel these out. You could draw a line through them, or you can leave it alone. It's up to you. I like to draw it out, or write it out, just so I can prove that I did some math work. And 50 divided by 2 is going to be 25. Now, if you're not sure of the solution, you can always do your math work to the side. Do your T-bone math, and just go ahead and show that, maybe in the margin of the paper, and maybe not somewhere in the middle of the paper where it might get kind of crowded up. I have 10z equals 400, and what's my coefficient? Basically, it's 10. And what you may be realizing now is that when you have a multiplication equation, you're basically going to be dividing by the coefficient. So divide by the coefficient. Cancel this out. And 400 divided by 10 is, pause if you need to, do math if you need to, 3, 2, 1. The answer is 40. Z equals 40. And when I ask for a solution, I'm asking for the entire phrase. 25 equals B. Y equals 4. Z equals 40. I'm not asking for 25, because that doesn't make any sense. That doesn't clear this up any. We want to know what the value of B is. We want to know the value of Y. We want to know the value of Z. Say what it is. Z equals 40. Boom. Done. There are some problems that you can try. And I'll let you try those and bring those to class with you. We can talk about those and make sure you can see those. Looks like you can see those. You might not be able to see the bottom one, so I'm going to pan that down just a little bit. That way, if you want to work ahead and copy some stuff down while I'm yapping, you can. And the last type of problem that I want to show you is something called a division equation. Now, these are not actual division equations. You shouldn't Google that. You might not come up with anything of substance. But I like to call them division equations because division is actually what's going on or what's being displayed, and you're being asked to do the opposite operation again. So I like to say that the opposite of division that's being shown is multiplication. And in this question, I love these kind of questions. They're my favorite because they go back so quickly. They're so easy. M divided by 3 equals 5, or M over 3 equals 5. I always tell people this. Look at the two numbers that are given to you and just multiply them. Because M divided by 3 equals 5. The opposite of division is multiplication. So I'm going to multiply both sides of this equation by 5. Or I can simply look at 3 and 5 and multiply them together. So the hint I like to give people is this. Just multiply these two values, and M equals 15. We're still showing balance, or we can still show balance, but I like to think that we can do some shortcutting once in a while. And if you want to show the long math, you can simply write times 3 here and times 3 here. Excuse me, I can't really show that. 3 times M over 3. And again, these are going to cancel out right here. And then, well, 5 times 3 is 15. Easy stuff. Now, there's another type of division equation that you may see, and it involves having a fractional coefficient. It's a fraction, it's a coefficient, it's called a fractional coefficient. But here's the deal. If we were to multiply by 1/3, that wouldn't get rid of that 1/3. We would have to either multiply by, maybe a reciprocal, because if I were to flip 1/3, that would be 3. And by multiplying this by 3, it would turn into 1, thereby canceling it. And by balancing the equation and multiplying both sides by 3, I would cancel this side out, keep x by itself, and I would be able to have an answer of x equals 30. So I guess the take-home point from this particular example is to multiply by the coefficient, by the reciprocal. Almost messed that up. Multiply by the reciprocal of the coefficient. And I know there's a lot of writing on a little board, and don't worry, I'll repeat myself. Multiply by the reciprocal of the coefficient. Multiply by the reciprocal of the coefficient. So the reciprocal of the coefficient here is 3, and by doing that, that's going to cancel these out, because 1/3 times 3 is just 1 whole. Think 3/3. And 10 times 3 is going to be 30. Now, I know you're probably wondering, does that actually work? If I take this, will it actually work? Well, it does, because 1/3 times 30, if I were to show my work, I'll do my work right here. 1/3 times 30 over 1, it equals 30/3. And 30 divided by 3 is 10. If you're not convinced, show your work and bring it in. Let's talk about it. Okay. I like to say shocking things in videos, apparently, about math, so let's talk about it in class. And right here, I don't have a lot of room to write stuff, guys, so let's just think, multiply the values that you have if it's a fractional coefficient value like that. And here's another example right here, and I want to do the same thing. There's not too much room there. Maybe I'll write it in another ink so we can keep it separate. Hopefully you can see the blue. This is blue. What's the coefficient of 2/3? I hope you wrote the same thing I wrote. 3/2 is the coefficient of 2/3. These will cancel out because 3 times 2 is 6, 2 times 3 is 6, and the last time I checked, 6 over 6 was just 1. If this is canceling out, then the answer is going to come from 8 times 2/3. 8 times 3 should be 24, and 1 times 2 should be 2. So this should be 24 divided by 2, which is another way of saying 12. Again, check your work. Plug this back in. 12 times 2/3 does in fact equal 8. And if you don't believe me, come into class and we'll talk about it. And I don't believe you unless you show your work, so how about you show your work too? Alrighty. There are a few examples on the bottom that I'd like you to try out. Mess around with this a little bit. I think you can see them. Looks like n over 6 equals 7 and 2/3 y equals 6. I know you'll try those out. Once again, I want to pan over to the vocab so you can use it as a way to bring yourself back to the explanation process instead of just the work process. And obviously, if you have to pause, rewind, go back, fast forward, all that other fun stuff, feel free and do that and enjoy that. Look forward to talking to you guys in class, and I'll see you soon.